This video is about roots and radical expressions. So when you are finding roots, you have worked with the square root before. So like say I say square root of 25, we're saying what number multiplied by itself equals 25. Or in other words, 5 times 5 equals 25. So the square root of 25 is 5. They're also going to present it as being the opposite. We said, okay, 5 times 5 equals 25. Well, you can write it as 5 squared equals 25, where 5 is the base, 2 is the power, 25 is the answer. But if we were to think of it backwards, starting over here, square root of 25 equals 5. So they're going to kind of present it both ways. So when you're working with a radical, then first you need to know what each piece means. So when there is a number out front in the check mark spot, this is called the index. When there is something under the radical symbol, that's called the radicand. And this would all equal the root. So when there is no index written, we assume there is a 2 there. So the index was 2, the radicand was 25, and the root was 5. Now we can change what's in the index. I could put a 3 here instead of a 2. Or just leaving it blank. Leaving it the blank is the same as putting a 2 there. So if I said cube root of 64, I want to know what number multiplied by itself 3 times equals 64. Well, we can just start at 2 and keep going. 2 times 2 times 2. Well, 2 times 2 is 4. 4 times 2 is 8. That's not 64. It didn't work out. So let's go back. What about 3 times 3 times 3? 3 times 3 is 9. Times 3 again is 27. That didn't work. Let's try the next one. 4 times 4 times 4. 4 times 4 is 16. Times 4 again is 64. That works out. Sorry, I wrote the wrong thing there. The cube root of 64 is 4. Now that works for small numbers, but when you start getting bigger numbers, it might take a while to go through that process. So you may also want to know how to do this on. So I'm going to pull up my calculator. This is just the regular computer calculator. I have changed it from being a standard, so from being the smaller one, to being a scientific calculator. And you'll notice it has a cube root button right here. So if we type in 64 first and then hit the cube root button, it will automatically show us that the cube root of 64 is 4. What if I get a little bit bigger? Let's say we're doing fourth root of 81. So fourth root is saying what number multiplied by itself 4 times equals 81. Again, you could go through the process and say, okay, well, what's 2 times 2 times 2 times 2? That wouldn't work out, so we would try 3 times 3 times 3 times 3. That does work out, so the fourth root is 81. But what if we want to do it in our calculator? Now, if you're using a different calculator, the order may be different. Some calculators, you would say 4, and then you hit this y radical x. When it has that check mark thing, that means it's a radical. So then you would hit the y radical x button, and then the 81. Oops. Some calculators would go that way. For this calculator, you do it backwards. You hit the radicand first, 81, y radical x, then the 4, and then the equals button. So with our radicals, there's even more to it than just figuring out what number multiplied by itself how many times equals the radicand. Looking at square root of 36, remember that the index for something like this is a 2. Now this was a different type of problem. Well, we have to think about it differently, I should say, because really there are two answers to this. There are actually two things that would both be the same number multiplying to be 36. First, if you did 6 times 6, that gives you 36. If you do negative 6 times negative 6, that also gives you positive 36. So there's really two answers here, 6 or negative 6. So there's really two answers there, and these are called the real roots of this number. Now they may ask you for something called the principal root. The principal root would be the positive answer only, just a positive 6. So let's look at one more problem. If we have 0.0625, this one I'm not sure about without using a calculator, so I'm going to get out my calculator first. In my calculator, we type in the 0.0625 first, then I hit the YX button, and then the 4, which gives us 0.5. So this one, it would depend on if they're asking us for principal roots only, or for all the real roots. If they say real roots, there's two answers. If they say principal roots, we would just use the 0.5. Now this is only for even indices. Our index here was 2, our index here was 4. If our index is odd, like the cube root, then there's only ever one answer. Let's say we want the cube root of 27. Well, we said three numbers multiplied by themselves. We would do 3 times 3 times 3. Thus, the cube root of 27 is 3. If I tried to make it negative, this time it doesn't work because a negative 3 times a negative 3 is a positive 9. Times one more negative 3 is negative 27. So, the cube root of positive 27 is 3, and the cube root of negative 27 is negative 23, or negative 3, but it never has two different answers. They may also ask you to solve problems involving fractions. Most often, all they really want you to do with this is recognize, hey, I can take the square root of 25, and I can take the square root of 49. Square root of 25 is 5, because 5 times 5 equals 25. Square root of 49 is 7, because 7 times 7 equals 49. This would be my principal root only. If they asked for all real, because this is an even index of 2, we would have to also find the negative. So some things with any roots, the square root or cube root or fourth root of 0 is always 0. And then for even roots only, so square root of a negative number or fourth root of a negative number, we just saw cube root, the third root, work. But if it's the square root or the fourth root of a negative number, a negative on the inside, that doesn't mean they couldn't put one outside, but if they put just a negative number inside, there is no solution. That does not work. So what they're also going to want you to be able to do is to simplify using numbers and variables. So we have negative 27c to the 6th. So you can do this two ways. I usually prefer the method where you're just breaking it down completely. So cube root, we would want to be looking for groups of 3 after we did what's called a factor tree. So negative 27 I know divides by negative 3. negative 3 and times positive 9 makes negative 27. Then we would break down positive 9. Now because we already had a negative 3, we're going to do negative 3 times negative 3 makes a positive 9. So now we would say, okay, the cube root is negative 3 times negative 3 times negative 3. C to the 6th really means C times C times C times C times C times C. And since it's the third root, we are looking for groups of 3. So within that group of 3, what's going to happen is all but one of them will just be canceled out. If there is a group of 3, then 2 would cancel out, 1 is there. Group of 3, 2 would cancel out, 1 is there. And the one that didn't get canceled out is moved to the outside of the radical. So we have negative 3 times C outside, which means, and then there was nothing left inside because it either all got moved outside or it canceled out, which means we don't need the cube root symbol anymore. And we just have negative 3c squared. Now something else that they may do instead is instead of just looking at groups of 3, they may say, well, negative 3 times negative 3 times negative 3, that's the same as negative 3 to the third. C times C to C times C, that's the same as C to the third. Same thing with the second group, that's the same as C to the third. And when you're taking the cube root would cancel out anything to the third. So we'd get negative 3 times C, which is still negative 3c squared. So there's a second way to think about it. So let's look at one more like this. So I'm going to break this down. 25 is 5 times 5. We have times x times y times y. Now there's no index written out front, but that just means we have our invisible 2 in this case. And so we're looking for groups of 2. 5s have a group of 2, x does not, but the y's do. One of them would go away, and one of them would get moved out front. So we would have 5y square root x. And that would be as simplified as that one can go. Now there's another special thing we have to worry about when our index is even. You cannot have the correct answer come out unless you use absolute value signs for some of these. And here's why. If I had square root of x squared, if I simplified that, that would just equal x. But let's try putting a number in. If I put in 3 squared, we know it should just equal 3 because our answer should just be that x. So 3 squared is 9, square root of 9 is 3, so that one works out. What if I did a negative 3 squared? We know it should equal negative 3 according to what it said, but when I do negative 3 squared, that gives me positive 9, which comes out as positive 3. So this one does not work. So when your index is even, and when you simplify to an odd power, that's x to the first, then we have to include absolute value bars because it will only work for positive numbers. So if we had absolute value bars around this, well, the absolute value of -3 is +3. So when your index is even and you've simplified to an odd power, then you must do absolute value bars. For example, if we did 4th root of x to the 8, we would have 8 times 8 times 8, 3, 4, 5, 6, 7, 8, and they all really have multiply signs between them. We have groups of 4. All of them except one get canceled out. The one that didn't get canceled out gets moved out front. And there's nothing left on the inside, so we don't need the 4th root anymore. So that equals x squared. We started with an even index, but we ended with an even power. That means no absolute value bars. But if we did the 6th root of y to the 18th, now this is getting a little bit bigger. I don't really want to write out 18 or y 18 times. So here is where a second way to think about the powers of variables will help us. If it's a number, we've got to just break it down like we've been doing. But with your variables, when you're taking the 6th root of 18, you can actually just divide those, and it will tell you what you would have gotten if you would have written out longhand and looked for groups of 6. Now we started with an even index, but we had an odd power at the end. That should be an O. This means we need the absolute value bars so that we can make sure our answer comes out positive. So let's do a couple more examples, and then we'll be done with our discussion on roots and radical expressions. So the 4, I'm going to still just break it down. 4 is 2 times 2. Well, we're looking for groups of 2 since no number was written in the index. 1 dies, 1 would make it out to the outside, so we get 2. And then with the variables, I'm just going to divide. 6 divided by 2 is 3. So we have to check, okay, we had an even number out front. These absolute value bars never need to be applied to the numbers themselves, so we don't have to worry about that. But since we ended with an odd answer, we have to put absolute value bars around that. So our final answer is 2 absolute value x to the 3rd. So one last problem. Fourth root of x to the 4th, y to the 8th. And again, this only matters when your index is even. If your index was odd, we don't have to worry about this at all. Now again, with variables, I can write it out 4 times and then 8 times and look for groups of 4. Or I can just divide by the index for my variables. So this would give me x to the 1st, y to the 2nd. X is the only one that came out with an odd power, so it's the only one that needs the absolute value bars. So that concludes our discussion on roots and radical expressions.